Hello, and welcome to Cross-Domain Command and Control with SaltStack Enterprise. My name is Nicholas Hughes, founding partner, CEO, and automation consultant at EITR Technologies. Today, we're going to discuss the hurdles encountered with systems management and security compliance across security domains. First, let's start by defining the problem. In a normal architecture involving distinct security domains, we may have several individual network enclaves, each at different classification levels. So, in my diagram here, I have a super secret, a semi-secret, and not quite so secret security domain in which they are distinct networks with their own systems and no connectivity between them. In order to manage those systems, administrators need to access those networks via dedicated workstations from which they can then manually administer the systems within. In scenarios where distinct security domains exist, you'll often find cross-domain solutions. Cross-domain solutions allow an isolated critical network to exchange information with others without introducing the security threat that normally comes from direct network connectivity. Basically, these systems perform deep inspection of the content traversing security domains. For instance, when data travels from a high security domain to a low security domain, we're predominantly worried about preventing information leaks. We don't want any of that super secret information to end up on the lower security domains. Conversely, when information travels from a low security domain to a high security domain, we want to make sure that we don't pass up any malicious code that would infect our super secret domain. Typical data applications for cross-domain solutions would be PII, HIPAA information, proprietary information and trade secrets, as well as national security information. You'll typically find these types of enclave networks in industrial control systems, national security systems, and safety critical systems, where it's very important to keep systems apart from your normal day-to-day operations. So, if we implement cross-domain solutions in between our enclave networks from the architecture before, we'd be able to transfer data between those domains. You'll often find cross-domain solutions in these scenarios. However, these cross-domain solutions normally target data use cases and do not allow administration traffic. You wouldn't be able to manage one system from another security domain. So, how do we solve a problem like that? There are plenty of automation platforms out on the market, but very few of them are well suited for this type of application. I evaluated the capabilities of many of the popular software tools, and one sets itself apart from the rest. SaltStack's event-driven IT automation platform provides the basis for solving many of your organization's automation, orchestration, and configuration management needs. I like to think of it as the giant multi-tool in my toolbox. Its built-in functionality and extensibility provide the ability to do just about anything you could ever need to do. Now, I've seen SaltStack implemented in the same type of segregated architecture we're discussing here. In those cases, instead of manually managing systems from a workstation, we have a SaltMaster, which is able to perform complex operations and orchestration across a massive amount of minions deployed inside of each network enclave. However, we still don't have a central point of administration and visibility across our entire enterprise. On a normal IT network, SaltStack Enterprise gives us a great way to manage multiple SaltMasters in the environment. SaltStack Enterprise is able to accomplish this through its unique operations framework, which uses an API-driven approach in order to coordinate operations on all connected systems. Each deployed SaltMaster under the enterprise architecture still gives us all the things we know and love from the Salt Open product: event-driven automation, cloud management, configuration management, remote command execution, and orchestration on any device on our network. These items are accomplished through SALT support for multiple operating systems, as well as the ability to communicate using an installed agent, agentless communication through SALT SSH, and SALT proxy minions, which can manage devices through APIs when other methods of communication are not possible. So, let's say that one of our masters is actually inside of an enclave network. What we can do is insert a cross-domain solution in between the operations framework and the SALT master within that enclave network as a sort of deep inspection proxy of the communication between the master and the enterprise server. So, bringing it back to our original architecture and our three disparate security domains, super secret, semi-secret, and not quite so secret, if we had a cross-domain solution in between, we can install a SaltStack Enterprise server in our most secure security domain and be provided a comprehensive view of our entire enterprise across all security domains from a single location. We can further illustrate this concept with a quick demo. I've mocked up a demo environment inside of Microsoft's Azure cloud. It's obviously not using an actual cross-domain solution or guard device inside of the cloud environment. Instead, it's using a makeshift proxy that I've developed in order to showcase this functionality. It basically takes all of the normal web traffic for the operations framework and drops it as files on the file system of the mock guard to simulate the deep inspection which occurs in normal guard operations. The SaltStack Enterprise server is located in our high security domain, since it will be aggregating information from all lower security domains below it. The low security domain has its own SALT master and a directly connected minion. Virtual network peerings connect the guard virtual network to the high and low virtual networks, but do not allow forwarded traffic between high and low. Not pictured in this diagram is a bastion host, which I use as jumping point into the demo. The bastion host can directly contact each of the three networks, but again does not allow routing between high and low directly. This bastion host is also relevant as I'll be showing some port forwarding in order to access the enterprise user interface. Okay, as you can see at the bottom, I have SSH to my bastion host in my demo environment, and I have forwarded port 8443 for access to the SaltStack Enterprise console on the high side server. I'm also forwarding port 8000 to port 80 on my load side minion server in order to show the installation of a basic web server. As was described in the demo architecture, you can see that the low side salt master is on the 249 network. The guard device is on the 250 network, and the high-side SaltStack Enterprise server is on the 251 network. You can see that the low-side server can access the guard. We get a message back from an SSH attempt. However, it cannot access the high side. We get a timeout message. It's not routable. Same for the high side server. We can access the guard on the 250 network, but cannot access the low side directly. The guard has access to both the low side and the high side networks. We'll get a response back from SSH on both of those. Now we'll jump over to the SaltStack Enterprise web UI. Okay, you can see that we have our low side master and minion showing up in our enterprise console, even though they're not directly connected. Our two low side servers, as well as our high side salt master, which is also the same system as our SaltStack Enterprise server, are all showing presence and are all reachable via Salt, despite the fact that the low side is going through the guard where the traffic is dropped to disk and transferred over to the other network. Let's go ahead and run a test ping and prove that we have connectivity. Latency will be increased to the low side network since it's not a direct network connection. However, we will still receive a response. Our test ping has completed and we have successfully contacted all systems in our environment. To anyone familiar with normal SaltStack network operations, this return doesn't seem like anything special. However, to anyone familiar with cross-domain operations, this is a big deal. Now let's go ahead and install a simple Apache web server on our low-side menu. You can see that I have a target group set up for my low-side menu. We can use the sample Apache state that's included in my demo environment. You can see that prior to the installation of the Apache web server, the port 8000, which I have forwarded to port 80 on the low side menu, is unreachable. And here we have our return from the low side menu, where the software has been installed and the service has been started. Let's go ahead and refresh our browser. And we have initiated a software installation across security domains. Also, a very big deal. Finally, let's switch over to SecOps and see if we can get policy compliance results across security domains as well. You can see that we have a minions list that includes both the high side server as well as the low side servers. We'll run an assessment against them. This will take a while to return. Well, the results are in. You can see that all of our minions have returned back. We do have 2 unknown results for each of our low side servers. I actually blocked those on purpose to show that based upon your guard inspection policies, you may not be able to check everything that you want to check. So you'd either need to tweak your guard inspection policies or your checks in order to accommodate cross-domain transfer. In our report here, we have the bulk of our information about compliant and non-compliant checks against the CIS CentOS Linux version 7 benchmark. In the check screen, we can remediate a finding across security domains. Let's go ahead and remediate our core dump policy. You can see that this check is non-compliant on all 3 of our systems. And we currently have a total of 272 compliant checks and 282 non-compliant checks. We should see the compliant number increase after the run is complete. Okay, the remediation is complete. You see that we have 3 returned minions. Now let's run another assessment and see how we did. Okay, our assessment is complete. You can see that our core dump policy is now compliant on all 3 systems, and the total number of compliant checks has increased. We have successfully remediated a security vulnerability across security domains. This concludes our talk today. I appreciate you tuning in. If you have any further questions, feel free to reach out to us at EITR Technologies. Thank you very much.